Well, hello again everybody. Well, as you can see, I've got the blue overalls on, some red gloves, and I'm actually back in the garage because today I'm going to be doing some more metal work. As you can see, I've got this large free draw unit, and it's actually really robustly constructed out of sheet metal and angle iron, and what I tend to do is I keep all my cutting discs and my welding spares and stuff like that in here. Now I've already started to empty this out, but here we've got some of them abrasive pads, got a dust mask there, got a buffing wheel, got some zirconium belts for a belt sander, and then we've got some more polishing mops and various abrasives. This right hand section, I actually call it my ouch drawer because it's full of these wire brushes, and generally when I put my hand in here I always get one of these wire brush, one of these little bits of wire down the side of my finger or something horrible like that, and yeah, it's always very painful and distressing, so I do avoid going in this drawer, but I do have to unpack everything. Here you can see we've got quite a few angle grinders, and I can see they've obviously been breeding in this drawer because it's absolutely full of angle grinders. If you're wondering why I have so many angle grinders, it's because I like to keep a different type of disc on each grinder, so some of them will be cutting discs, some might be grinding, some might be sanding, and I may also use separate angle grinders if I'm working on stainless steel, mild steel or aluminium, because I don't want to get cross-contamination off the wheels from one material to another. So yeah, that's why we have so many angle grinders. Then in this side, this is my welding drawer. So you can see I've got all the welding clamps here. Here's a big block of copper, which is a copper heat sink. You tend to use things like this when you're filling in holes on a piece of sheet metal. If you've got to fill holes in a metal dashboard, for example, put a piece of copper behind it, and then you can use the MIG wire directly onto the copper to kind of build up a patch. So yeah, that's what that's for. Some welding gauntlets. Again, various types of welding clamps here. And a pair of lovely soft TIG gloves. Here you can see I've got one of my old 90-degree squares, and I think this might have been one of my apprentice pieces. I'm not exactly sure. It looks homebrew. It's probably why on my shelves are a little bit wonky, because it's almost certainly not 90 degrees if I made it. And I suppose I should have said the reason that I keep this one in the welding section is it's made from aluminium, which means that if it gets splattered with hot steel, the splatter just rubs off it. Now some of these boxes have been in these drawers that long, even I don't know what's inside them, so I'm taking a look for the first time with you. Oh, it looks like we've got some, oh, that must be some screens for my welding mask. Oh, we've got some half sharpened TIG electrodes. We've got, what are they? Oh, more TIG electrodes. Grey TIG electrodes, I think they're multi-purpose, aren't they, the grey ones, AC and DC, you can never remember. And some spare tips for my plasma cutter and my MIG welder. Finally, just taking a look in the bottom drawer, we can see we've got a needle gun here. So I actually bought this for removing some rust and stuff off the chassis on the Chevy. This is actually quite a useful tool. It's one of the better Clark tools, so I would actually recommend one of those if you've got some serious de-rusting to do. Also got this thing, the name of which has completely gone out of my head, but you use it for working on sheet metal work when you want to weld it together. It kind of creates a seam, and it's also got a punch on it which you can use for punching out holes for spot welding.
Just put the tool on here, pull the trigger. Now you see that hole? Like that was like, went through like nothing. And that's 16 gauge. So let's just put the tool in here, and as you go along, you could see it's making a nice offset flange.
Here's a 90-degree air drill. Again, this found lots of use when I was building a kit car, and I had to get in a lot of tight places to drill holes for rivets, so I did actually use this quite a lot. Now, although I've got quite a few of these air tools, I don't really use them anymore. I'm not a fan of air tools because generally I think that modern battery tools do a better job, and you do need an awfully big air compressor to actually run these tools effectively. So I don't actually think I've used any of these air tools in many years, so I'll probably try and get rid of them and maybe replace them with their electric counterparts. And this thing's a rivet gun for installing pot rivets, and again, I used this quite a lot when I built my Ginetta kit car to actually rivet the body together, but again, haven't used it in many years. See, we've got a big old air line here. Got another small, cheap and nasty Silverline air sander, which from memory is pretty rubbish. An air operated cut-off saw. Again, I think I bought this for making up some exhaust or some manifolds for a turbo. Again, this hasn't seen the light of day in many years. Paraffin spray gun, actually fairly handy for degreasing engines when I used to do that kind of thing. Big bag of various air fittings, and I think that's probably okay, we've also found a bug in the drawer. Not exactly sure what it is, but he certainly doesn't look very impressed, so I suppose we better let him go. I'm sure most of you are wondering why I'm unpacking this free drawer unit. Well, the reason being is I want to turn it into something else. I actually want to convert it into a pedestal for a new machine that's coming. Now, I'm not going to give you a lot of details about the new machine that's coming. I'm keeping it all a secret, but I promise you it's going to be a lot of fun. The problem I've got is this free draw unit here. It's actually too high, and if I put the machine on top of it, I won't be able to reach the top of the machine. So I need to cut this pedestal down. So I bought some fancy new tools to help me do that, and I thought this thing's heavy, so I was hoping you'd just give me a lift with it today. So let's crack on. Oh, these really are quite heavy. Oh, that's heavy. I can't believe it is my welding blanket. I was looking for this everywhere the other week. God, there it is. And also a little small welding blanket with a hole burnt through it. Didn't obviously do its job very well. Just goes to show you can set fire to anything if you try hard enough. Many years ago when I made this for a completely different purpose, I think I had some other piece of machinery set on top of it which was a little bit delicate, so I had an MDF board on it, and that MDF board has got a little rubber mat on top, but it's actually screwed on with about 300 screws. So my next job is actually to take this top off, because I'm actually going to replace this with a thicker piece of steel which my new machine is going to sit on. I'm actually wondering if I can lay this down, or if it's going to be too heavy for me. Ooh, it is quite heavy. I think I would rather drop it onto a block or some piece of wood, something with a bit of give in it. So let's see if we can do that. Something like that. Bombs away. Now, I wasn't worried about damaging this because it really is very, very substantial, because it is constructed from pretty thick, I think that's probably 3-4mm angle iron all round, and then it's actually skinned in, I think it's probably something like 1/8 of an inch thick steel plate. So this thing is very heavy. See if we can remove some of these pesky screws now.
One eternity later.
God, that was a job. So you can see that my drawer unit does have some quite substantial casters on it, but they aren't going to be heavy enough for the machine that I'm going to have sat on it. So these old casters are going to come off, and I'm going to put some new ones onto here. Maybe a bit of tappy tap tap will be in order. Okay, straight back. 1, 2, 3. You can see at the corners here we're actually cutting through a fair amount of metal, and the actual edge that it's left is very good. It hasn't got any burrs on it, and well, it's actually pretty polished, isn't it? So yeah, that saw's a beast. Now what I've got to do next is I've got to remove these corner pieces. I'm wondering the best way to do that. It might actually be easier to chop through them with the saw again, and then maybe just try and grind these welds off. I think that's what I'm going to do. But again, you can see we really don't have any trouble getting through this stuff. The same as my bandsaw, I'm going to have to move it around a little bit within the workshop just to make best use of the limited space that I have. So again, we're going to be installing some casters, except these casters are a little bit sexy, don't you think, in that these are actually a jacking caster which are designed for machines. So they have this very hard nylon wheel, but they also have this very rigid rubber block. So what you can do is once you've got the machine in position, you don't want it rolling around or vibrating. What you can actually do is you can jack these feet down. So okay, so when you don't want the weight of the machine on its wheels while it can roll, you can jack the rubber pad up as I've done there, and then when you want to move the machine, you flick this little lever and then you can wind the little pad down again. And it looks like you can also screw a rod into here, maybe to give you a little bit more leverage, and that's perhaps why I'm just struggling to undo this one. Okay, well this particular caster did take a little bit of persuasion here just with a spanner, but now I've done that, it's moving quite nicely. Probably going to have to write something on here so I actually know which way to wind these things, because I'm bound to forget, knowing me. Now of course, having removed the old casters from here, we find that these are on a different hall sensor, and they're actually the base of them, it's actually quite a bit smaller, and I can't get the original studs through. So what I'm going to have to do is I'm going to cut these studs off now, and I'm going to bolt these on. I think it's actually easier to do this now, put these casters on before the thing's reassembled, because I can simply lift the base and modify it at the moment, where when it's all welded back together it's obviously heavy. So I'm going to go ahead and I'm going to cut them studs off, and then when I've done that I'll bring you back. And in tonight's News at 10 we'll be discussing the price of fish. Now luckily these casters that I bought do come with some nuts and bolts. I'm not sure they'll be long enough, but we're going to give them a try. I think what I'll do is I'm going to bolt these on now. Oh god, I'm too feeble to open a plastic bag. I'm going to edit that out so nobody will see it. As you can see, these casters do come with some nuts and bolts, so it saves me messing around with those horrible roofing bolts with the square nuts that I used last week. Okay, these aren't going to be long enough though, so unfortunately close but no cigar. So I think that the perfect nuts and bolts to put these casters on are these roofing bolts, because they've got very low profile heads, so that's what I'm going to use. Well, that's all of our casters mounted. So what I think I want to do now is I want to lower these feet down. So is that going to go the right way? Okay, let's put your feet up. I'm going to click this lever. Let's lower all the feet until the thing can sit on its caster wheels. Well, it's definitely doing castery type things. I think I'm going to weld this thing up about 3/4 of the way down this angle. So I think that's going to be probably something like that. Well, I think that saw works really well, but it does create quite a lot of mess. So I'm just setting that up with a magnet. Well, it's a day later now and I've finished off shortening the machine pedestal, and I've gone ahead and I've actually welded it up, and I've got to admit it actually rolls quite nicely. Now the next thing that I want to do is I want to put a drip tray on top of here, because I think I said to you earlier there's a machine going to be sat on top of here and it's going to have coolant sloshing all around of it, and I want to be able to collect up some of that coolant. So I've gone ahead and I've got a piece of sheet metal here. So I'm going to take this piece of 6mm plate and I'm going to sit it on top of the pedestal. Now you can see the pedestal does already have a top on it, and I think that top's probably just a couple of millimetres thick, but all in all I think by the time we get it on here and it is fully supported around the edges with some angle iron, I think it should be quite rigid enough for what I want. But the other thing that I'm going to do is I'm going to put an edge on here to make a big drip tray to catch all the coolant which I'm going to be using on the machine, and hopefully save some of it from the garage floor. And I also might add some form of cooling system, a suds pump to this machine. Haven't decided yet, that'll be for the future. But the first thing I've got to do is I've got to bolt this piece of plate to here. Now of course I could just weld it on, but to be honest I did want the ability to be able to take it off and change it, and I think it will be fine bolted on, so I've marked out where I'm going to put some bolts. And to secure this plate onto the table, I'm going to bolt it on, and I've got some of these carriage bolts that have got the domed head on them, and I think it's probably a good idea to use them because I don't want any sharp edges on bolts where swarf and things will get trapped. And I think because these have got a low profile head, I think these should actually work quite well in this application. The other thing is, of course, they do have this square end on the shank here, so it means there's going to be a little bit of filing involved at some point, because otherwise they just spin when you try and tighten them up. But I think that I can probably get away with drilling these about 11mm, so hopefully I won't have too much filing to do then. Now an 11mm diameter hole drilled into a piece of thick steel like this, it's actually a pretty big hole to actually hand drill. I enjoy breaking my wrist as much as the next man, but it does grow tiresome after a while, so I've actually got a cunning plan, and again couldn't resist buying another tool just to make this job a little bit easier. So let's take a look at that. So we've got another tool made by Evolution. I really should write them a letter and try to get some sponsorships, because I have spent quite a bit of money with these Evolution guys recently, but I've got to admit I've been pretty pleased with the tools that they provide. Although they're not the cheapest tools, they are very good value and they seem to be built very well. Anyway, let's see what's in my box. Does anybody know what that is? Can you guess? Have you ever seen one before? Well, I'm guessing that if most of you haven't worked in a fabrication shop or have come from a fabrication background, you probably won't know what this is. So I'm just going to tell you, this is what they call a mag drill, and it's often used on site where you have to drill quite big holes. And quite often when you're drilling those big holes, you use something called an annulus cutter, which has actually got coolant that pours out through the middle of the cutter. But I'm not going to be using coolant today, that's a little bit messy, and I don't need to drill such a big hole. We have some specification information printed on the side of the drill, so let's take a look at that. So it says that it uses 1200 watts of power, so we've obviously got a very substantial electric motor here. It says that we've got a magnetic clamping force of 1,300 kilograms, so when we engage the magnet on this drill really isn't going anywhere. Using a conventional twist drill, it says we can drill up to 13mm or ½ an inch, but when you're using one of these annulus cutters, you can actually go up to 42mm in diameter. Let's take a quick look at what comes in the box. Okay, we've got a guard, don't need that. So I said that these can be used with coolant, and it actually feeds coolant out from the chuck here, but we're not going to use that today. And I am hoping that this drill does in fact come with a chuck, which thank goodness it does. I can see that it does also come with an instruction book, but I'm not going to read that because I've used mag drills before. And seeing as we're stealthing today, we may as well go ahead and remove the plug condom. I mentioned that the drill has a magnetic base. Well, that magnetic base is in fact an electromagnet, and what we can do is we can actually switch that magnet on and off. So what you do is you get the drill into position, you switch the magnet on, and then you do your drilling. The annular cutters that are normally used with this drill, they do have a special shank with some square edges on them, which are designed to fit directly into the drill itself. But because we're using this Jacob style chuck, we have to go ahead and fit this adapter piece into the chuck body, so let's do that. Before installing the chuck, there is usually a couple of Allen screws that you have to undo, so let me do that. And again, it's not necessary to rive on these things, all we need to do is just nip them up a bit. So to demonstrate the utility of this mag drill, imagine we're working on site and we've got a big hole to drill, and maybe we want to drill it into the side of a steel column or something like that. I really will show you the utility of this magnet now. So basically you position the mag drill where you want it, switch on the magnet, and ta-da! It's going to stay there. As long as the drill has power, it will stay there. Let's switch the motor on. And when you finish the drilling and it comes time to actually remove the drill, very simple, all you have to do is just switch the magnet off and off it comes.